Sun won't live forever. In billions of years, it will transform. Expand into an enormous red giant and swallow the Earth. Humans will be long gone. But what if this process happens now, while we are still alive? What would our planet look like? It's a world we can barely imagine. The story of what happens to our planet as the sun turns into a red giant and we struggle to live in the aftermath. Our closest star is a giant ball of glowing gas, more than 870,000 miles across. The sun is so large that 1,000,000 Earths could fit inside it. But its size is just one astonishing aspect of our sun. Inside its core, hydrogen atoms are constantly smashing together. Every second, these collisions produce more energy than 2 billion nuclear plants could generate in a year. The light and heat warms our planet and gives our world life. But the fuel inside the sun won't last forever. Eventually, the hydrogen will run out. We won't be here to see it because the sun's life spans billions of years. But what if we were? What if our planet, with our cities and population, has to deal with a sun that begins to age rapidly? If we were able to jump forward billions of years at a time, what would we see? And how long could we survive? Imagine that this experiment begins today. It's an ordinary summer morning, but overnight, the sun ages millions of years, adding more light and more heat to our planet. Up close, it appears the same. But the sun is actually producing more energy than it does today. As it consumes hydrogen, the sun's core becomes smaller. And as the amount of hydrogen decreases, the core is compressed. This increase in pressure means more hydrogen atoms collide. The sun creates more energy, and the Earth is hotter. People in New York City face temperatures over 130 degrees Fahrenheit. the average global temperature has gone up by 36 degrees. Cities in Australia and Asia experience temperatures that soar past 145 degrees. From Egypt to England, no corner of the world is safe. Even the coldest places on Earth are much warmer than usual. In Greenland and Antarctica, snow and ice begin to melt. Changes here affect the entire world. It would take years, but temperatures this hot would cause all the ice at the North and South Poles to melt. The huge ice shelves of Antarctica and Greenland would slide into the sea. Sea levels around the world would rise by more than 200 feet. Manhattan and coastal cities around the globe flood. San Francisco, Los Angeles, Miami, and most of Florida would be overwhelmed. A world with too much sun becomes a world with too much water. Under our rapidly aging sun, non-flooded cities are also affected. Crippled by overuse, air conditioners stop working. At 130 degrees, the power grid can't handle the load. Overheated cities struggle to keep the power coming. Around the world, people are overwhelmed by the intense heat. We release extra heat by increasing blood flow to our skin. That's why it turns red when we're overheated. The hot blood is cooled as our sweat evaporates. But when the temperature outside is above 98.6 degrees, it's harder to cool down. Our body temperature starts to climb, and our brains can't cope. If our bodies get just 6 or 7 degrees hotter than normal for an extended period of time, we can suffer permanent injury or death. Regular temperatures of 130 degrees are hard for us to handle. Several years ago, excessive heat killed more than 500 people in Chicago. During a 5-day stretch, temperatures reached as high as 106 degrees. But this heat wave is permanent. A brighter sun has shattered our world. And soon, the planet will look like a total stranger. During the course of its life, our sun will eventually burn through all of its hydrogen fuel. It's a natural life cycle that will take billions of years. But if we speed up that aging process, what effects might it have on Earth? Overnight, the sun ages another 5,000 years. It's still 36 degrees hotter than it used to be. These temperatures flood cities like Manhattan. But other cities transform in different ways. Bamboos and long grasses take over where evergreens and maples used to be. If these conditions persist, cities like Chicago and Toronto will have foliage like Southeast Asia. Around the world, climate is dramatically different. The intense heat is evaporating water faster than ever before. Immense amounts of water are sucked into the sky. Tropical storms lash the planet. But even though there's lots of water, the rain is actually killing some plants. And part of the reason is found in the mountains. Here, the pounding rain causes massive erosion. As new rock is exposed, minerals start to bind with carbon dioxide. Over thousands of years, it's stolen from the atmosphere. But plants need carbon dioxide to breathe. Some absorb it more efficiently than others. And in this hotter world, they're thriving in new locations. But other plants normally found in the northern hemisphere aren't adapting well. Maples, oaks, and evergreens struggle with the dramatic climate change. The rain that's changing the planet normally cools us down too. We're one of the best animals in the world at regulating our temperature. Water can literally take heat away from our bodies. But in humid, 130-degree weather, it's getting hard for us to get rid of our sweat. Under such extreme conditions, our bodies can lose nearly a gallon of water an hour. We're at the limits of our endurance. And the heat won't let up. To make matters worse, the concrete and steel of a big city collects the heat. Cities can be more than 7 degrees hotter than the countryside. To survive in such a hostile world, there would be an enormous migration to the countryside, where the temperatures are slightly cooler. In the old world, this used to be a fruit orchard, helping the United States grow 150 million bushels of apples a year. But like other plants in the northern hemisphere, these apple trees are not doing well. It's just too hot for the plants to grow. And it would be difficult for us to harvest the fruit. Working in such intense heat quickly raises our body temperature to dangerous levels. The sun is on a relentless march to becoming a red giant. But before it gets there, the heat will continue to rise. And we'll be completely wiped from the surface. This is a world where the sun is nearly 2/3 of the way through its life. It's something that won't happen for 3 billion years. But in this experiment, we've sped up the aging process to see what effects the sun's old age would have on Earth. Hydrogen used to make up most of the sun's core. Now, it's severely depleted. But even though there's less hydrogen, the sun is actually hotter. As the hydrogen decreases, the outer layers of the sun exert growing pressure, forcing the remaining hydrogen to fuse more quickly. It's a doom cycle that will end in the sun's death. If the Earth we live on now was orbiting this aging sun, it would seem only about 30% brighter than it does today. But it's not the brightness we react to as much as the heat. Seasons as we once knew them no longer exist. The temperature now soars past 212 degrees, hotter than the boiling point of water. Humans simply can't survive in this heat. The liquid on our eyes would quickly evaporate, and the severe heat would blind us. Our lungs are filled with alveoli, delicate membranes that absorb oxygen. They can't handle the 212-degree air for long. The heat would suffocate us. It's not the only thing under siege. The magnetosphere is an invisible field circling our planet, which protects us from blasts of solar radiation. But this hotter sun is producing more energy than ever before. Like a shield absorbing too many blows, the magnetosphere begins to weaken, and more solar radiation gets through to the planet's surface. Exposed skin is quickly destroyed. The only place humans can survive is underground. Here, ragged remnants of the population are shielded from the vicious UV radiation and crippling heat. But we can't burrow too far. The temperature rises over 15 degrees Fahrenheit for every 1,000 feet down. We're literally trapped between the deadly breath of our star and the internal heat of our planet. If we want to explore the surface, we can't go unprotected. Modified spacesuits are a possible solution. Designed to battle the sun's searing heat, these suits come with their own internal cooling system and oxygen supply. The suits are white to help reflect the torturous heat. But anyone wearing it will have to struggle with the suit's weight. More than 100 pounds. It's the only way to survive on the surface of the planet. A world radically different from anything humans have ever been exposed to. and temperatures continue to climb. It's now over 300 degrees. Cities bake under the searing heat. Water evaporates far more quickly than it does under our present sun. Around the globe, water levels are falling. The sun is literally boiling water off our Earth. The surface of the planet is as hot as a stove. Manhattan is no longer an island, but a city on a barren hill. Concrete and steel canyons that were built over hundreds of years are now deserted. Even water hidden in the sewers begins to evaporate. And doors stick shut as the intense heat forces the metal to expand. While open water is evaporating, bottled water can still be found. Simple physics is keeping it safe. As the water heats, pressure increases inside the bottle, raising the boiling point. And even at 300 degrees, this water won't boil. Yet. But cans of soda and other carbonated drinks suffer a different fate. As heat builds inside the cans, CO2, the gas that gives soda its fizz, is forced out of the liquid. The pressure inside will eventually become too much. As the temperature continues to climb, the effects are much greater. Coastlines around the world look entirely different. More and more of the ocean's water disappears. Half of the water in the Pacific Ocean would be gone. And the water is hot. The average surface temperature of the oceans used to be about 63 degrees Fahrenheit. Now, it's rising rapidly. Thousands of feet below the surface, the water still cools. Fish that thrive in warmer waters still cling to life, for now. Even hardy creatures like cockroaches can't survive. They don't have lungs and can live for weeks at a time without food. But as they venture into the sun, they eventually die. overwhelmed by the heat. As huge bodies of water burn off into the sky, the Earth's climate continues its transformation. More and more water is evaporating and condensing. Clouds stretch higher and higher into the sky. And storms get increasingly larger. Megastorms, hundreds of miles across, lash the planet. If temperatures keep climbing, the air eventually becomes too hot for the rain to hit the Earth. It would evaporate before it ever reached the ground. For now, the enormous banks of clouds reflect some of the sun's heat. But ever-rising temperatures on Earth can't be stopped. Deserts take hold around the world. Even the hardy bamboos and grasses are overwhelmed. Plants can't survive the tremendous heat. The death of plant life makes the brutal conditions on Earth even worse. As plants and animals die, they release carbon dioxide and water vapor into the sky. Both of these gases are part of our thermostat. They help trap heat on the Earth, keeping it warm enough to sustain life. But now, as plants and animals rot, and water evaporates at an astounding rate, it creates an intense greenhouse effect. Too much carbon dioxide and water are being released. Our thermostat is broken. It's more than 300 degrees on the surface of the planet, and climbing. But some life lasts longer than others. Cyanobacteria would be among the final living organisms on the planet. Even in hotter water, this colorful algae sucks in carbon dioxide and water to live, and produces oxygen. As the dark curtain of bacteria grows across the ocean, it blocks the sun over large areas. And no sunlight means there will soon be no life. In a world of raging storms, where humans are struggling to survive, one of the most important necessities of life is disappearing. With the death of plant life, there's less oxygen in the air. Huge amounts of new water vapor also lower the concentration of oxygen. Normally, the air around us is about 20% oxygen. Under these conditions, it falls to less than 10. It's not enough for us to breathe or sustain fire. While lightning lashes the planet, fire doesn't burn. For now, even though lightning strikes, our buildings survive. But worse is yet to come. What's left of our planet is going to change even more dramatically. Our sun is aging rapidly, marching inevitably to its death. This is the sun as it would be 4 billion years from now. The remaining hydrogen in the sun's core is under tremendous pressure, crushed by the weight of the outer layers. Hundreds of millions of tons of hydrogen are fusing together every second. It's an Earth we barely recognize. The surface of the planet is now 700 degrees and rising. It's too hot for us to survive. Even the most sophisticated suit can't protect us from the blistering heat. And we can't survive underground either. At these temperatures, human life on Earth is finished. Every last drop of water on the planet is evaporating. The oceans become vast, salty deserts, sucked lifeless. As the oceans vaporize, Earth is shrouded in clouds, which reflect the sun's rays. But that doesn't make it cooler. The heat is trapped in this gas envelope. But heat isn't the only punishing problem. The air pressure on Earth is now 270 times what it once was. If humans were on the planet, it would feel like every square inch of our body was being crushed under the weight of 4,000 pounds. Eventually, pressurized containers are destroyed, crushed by the Earth's enormous atmosphere. But even highly volatile liquids like propane and gasoline still can't burn. In these conditions, there's not enough oxygen to sustain flames. But the extreme heat is more than enough to begin melting what we've left behind. Polyester and plastics turn into a molten mass. The extreme temperature also marks the death of anything made of concrete, which was created with water. Now, in over 700-degree heat, this trapped water evaporates explosively, turning the concrete brittle and dusty. The metal rebar inside the concrete, which gives it added strength, expands in the tremendous heat. Combined with the evaporation of the moisture, The effect is dramatic. Some ancient monuments are still able to withstand the heat. Even 700 degrees isn't enough to damage the limestone of the pyramids, or the sandstone that makes up Stonehenge. They wouldn't melt just yet, assuming they were still around. But these incredible temperatures aren't stable. 700 degrees isn't anywhere near the most extreme the world will see. The greenhouse effect gets worse. Temperatures shoot up towards 2,400 degrees. This last radical increase is the beginning of the end. More and more of the water vapor circling the planet escapes our atmosphere and travels into space. Water that makes up the clouds is bombarded with UV radiation from the sun. The radiation splits the hydrogen off from the water molecule. As the hydrogen escapes to space, the oxygen stays behind, and the world is remade. About 5% of the Earth's crust is made of iron. As the oxygen returns, the iron rusts, and the planet begins to turn red. As the oxygen levels climb again, the extreme temperatures spark a deadly cycle. There's enough oxygen for fire to return. Anything that survived now burns. Even without the fire, the limestone of the pyramids now crumbles. And the sandstone of Stonehenge melts. The last artifacts of our existence return to the planet. Earth is now a scorched, rusting world. The sun is just 40% brighter than it once was, and what's left is completely consumed by fire. The sun that gave us life now has scorched the planet bare. This is the Earth. This is the Earth. Billions of years into the sun's future. Our sun has aged, and we've tried to live under the light of a hotter, brighter star. Our cities are gone. Our manufactured world destroyed by the blistering heat. Any kind of life has become impossible. The sun has aged more than 6 billion years. It's time for the end, not just of life on Earth, but of the planet itself. Deep inside the sun, the last of its hydrogen fuel is consumed. What remains is a core of helium. It takes enormous pressure and heat to make the helium fuse. But now, the immense force of the sun's outer layers bears down, and this fusion begins. The powerful ignition actually propels parts of the sun out into the galaxy. As the sun continues to expand, the Earth is eventually baked in 3,600-degree heat. Our planet is scorched smooth. Its relentless growth has brought the sun just a few million miles from Earth. It has already swallowed Venus and Mercury. Now the rising sun completely fills the horizon on what remains of our planet. It's over 200 times bigger than it once was. Humans would only be able to witness this event if we had somehow escaped the Earth and were observing our planet from afar. Perhaps Jupiter's moon, Europa. It's always been outside the habitable zone of our solar system, too cold to support human life. But the red giant has changed that. Temperatures reach habitable levels even at the far edges of our solar system. But Earth looks nothing like it used to. No signs indicate it could have ever sustained life. And then, the final act. The massive outer edges of the sun begin to slow the Earth's orbit. Our planet is now a fireball, burning up like a meteorite. In a blast of unimaginable heat, we're swallowed by the sun. This has been an experiment. As our sun ages, it will slowly become hotter and larger. It will eventually become a red giant and transform our solar system. None of this will happen for billions of years. But even now, our life and the life of our planet are balanced precariously. The Earth is just warm enough, just bright enough